Our next problem is cos A divided by 1 minus sin A should be equated to secant A plus tan A. Here also we have bigger ratios on our right hand side, so I am taking right hand side one. Secant A can be written as 1 by cos A, tan A can be written as sin A by cos A. So by taking LCM we have cos A and on top we have 1 plus sin A. But in the left hand side we have 1 minus sin A in the denominator. So multiply that 1 minus sin A by 1 minus sin A. So here by multiplying on the top we have 1 minus sin square A divided by cos A into 1 minus sin A. 1 minus sin square A can be written as cos square A from the identity. So and below you have cos A into 1 minus sin A. So 1 cos A in the denominator and 1 cos A in numerator gets cancelled. So you'll have cos A divided by 1 minus sin A. That's the LHS. Sometimes it happens because sometimes some complicated expression is given on right hand side. Just take the right hand side and prove it to left hand side. Our next question is sin A into tan A divided by 1 minus cos A, which should be equated to 1 plus secant A. So obviously here left hand side is the complicated one. So now convert this one. So take sin A and tan A, convert into sin A by cos A divided by 1 minus cos A. On the top you have sin square A and this cos A comes to denominator, cos A into 1 minus cos A. So sin square A I can write 1 minus cos square A using identity divided by cos A into 1 minus cos A, which is equal to, so top we have A square minus B square, 1 I can write 1 square, so this is like A square minus B square. So I want to take it as A plus B into A minus B. So you have 1 plus cos A and 1 minus cos A on the numerator, and below you have cos A into 1 minus cos A. 1 minus cos A, 1 minus cos A gets cancelled. So you will have 1 plus cos A by cos A. I want to split this denominator into these two terms. So you will have 1 by cos A plus cos A by cos A. Cos A gets cancelled. 1 by cos A I can write secant A and this is 1 here. So hence the RHS. Our next question is 1 plus cot A minus cosecant A into 1 plus tan A plus secant A, which should be proved like 2. So seems to be complicated on left hand side. Consider that one, left hand side one. So write down that I am converting this cot A into cos A by sin A, and this one as 1 by sin A, and here 1 plus this one into sin A by cos A, and this one 1 by cos A. Now take the LCMs in two expressions. So you have sin A for the first one, and on top you have sin A plus cos A minus 1, and here also you have cos A as LCM, and you have cos A sin A plus 1, which is equal to, here if you see, if you group up this sin A plus cos A, sin A plus cos A as one term, then you have A minus B into A plus B in the numerator. So I can write sin A plus cos A whole square minus 1 square divided by, you have sin A and cos A in the denominator, which is equal to, I want to expand this, it is sin square A plus cos square A plus 2 sin A cos A for that expansion, and for this expansion, for this one, and minus 1 for this, divided by sin A and cos A. So sin square A and cos square A, from using identity I can write 1, but this 1 is cancelled out with this minus 1. So these two gets cancelled. The remaining thing is 2 sin A cos A divided by sin A cos A, and these two also gets cancelled, so remaining thing is 2. So don't get scared about the bigger expressions. If you convert into smaller expressions or smaller ratios, then somehow you will get some relation. So here I got algebraic relation, and then using identity I just cancelled the terms, and then we reached the right hand side. Our next question is square root of 1 plus sin A divided by 1 minus sin A is equal to secant A plus tan A. That is what we need to prove. Take LHS. So you have square root of 1 plus sin A by 1 minus sin A. So I intentionally put a bigger square root because I want to rationalize this term. So I want to multiply with the 1 plus sin A by 1 plus sin A and divide with 1 plus sin A. So by doing this one, you will get a square root of, in top you have 1 plus sin A whole square, and in denominator you have 1 minus sin square A. 1 minus sin square A. So that is equal to 1 plus sin A whole square divided by, this can be written as cos square A, so whole root. If you take out this root and square terms, you will have 1 plus sin A by cos A. Split this denominator to the numerator terms. So you will have 1 by cos A plus sin A by cos A, which will give, this is secant A plus this is tan A, hence the right hand side. So main thing is rationalizing this factor and then take out the square roots. Our next question is square root of 1 minus cos A divided by 1 plus cos A, which should be equated to cosecant A minus cot A. So this problem also we can do like previous one. Take LHS, square root of 1 minus cos A divided by 1 plus cos A. I want to rationalize the denominator, so I will multiply with 1 minus cos A and divide with 1 minus cos A. So you have, on the top you have 1 minus cos A whole square divided by, below you have 1 square minus cos square A. So which will give square root of 1 minus cos A whole square divided by, using identity I can write sin square A for the denominator, which will give, take out the square roots and squares on both sides, you will have 1 minus cos A by sin A. If you split this sin A to the two terms in the numerator, you will have 1 by sin A minus cos A by sin A, which will give cosecant A minus cot A, hence the RHS.